Okay, so today's notes are going to be a little bit longer than normal, and we're going to actually do 92 and 93. 93 is not a whole lot different than 92, other than you're going to have inequalities instead of the equal sign in between. Okay, so I'm going to put them all in there together. So more than likely, when you get done with the notes today, you're not going to have time in class to work on the try it. So you will have some homework over the weekend, and we will grade it on Monday. Okay. All right. So we're working with graphing, and this time we're used to equations having a straight line when we graph, which is the y equals mx plus b. Okay, but when we have an x squared or a quadratic equation, okay, so minus this y over here, anytime you have x squared, we call that the quadratic equation. Okay, so when we graph these, it's not going to be a straight line, it's going to be a curved line, and those curved lines are called parabolas. Okay, so you're going to be practicing with parabolas. Okay, so we're going to start out super simple, plugging them in, and then we're going to build up to having an equation that looks like this. Okay, so you can always, anytime you have this, you'll just have an equation. You can always make a, I call it a t-graph. Okay, I'm not sure what the actual right word is for that, but right off my mind right now. But you pick values, and we always pick the smallest of the values. Okay, so 0, 1, and 2. Okay, but we need to know when it curves to go the other side, so that's why we pick a -1 and a -2. And these are just smaller numbers to work with. If you wanted to do 0, 5, and 10, you could do that. Okay, it just makes the graph bigger, and we don't want to have to really graph big numbers. Okay, so all you're doing right now is plugging these values into this equation and tell me what you get for y. Okay, so I want you to do that right now. Okay, so checking your values, you should have got 4 when you plugged in a -2, so a -2 times -2 would be a +4. So these should be the values that you wound up with. Okay, so now all we're doing is graphing. Okay, so we have our x and our y line, so my y line and my x line. I will get you graph paper when you do your lesson quiz so that your graph papers are nice and clean. While we're doing the try it, just try to make sure that your graph, and what I talked about is when you're counting by 1, make sure your proportions are equal on these so that they look like, it's not like this and then the next one's way over here. Okay, make sure it looks equally proportioned. Okay, when you're putting those lines in there. Okay, so we've got our x and we've got our y's. Okay, and now we're graphing. So a -2, +4. So -2, so that's going to the left. So I'm going over 1, 2. Okay, and then I'm going to go up 4. So 1, 2, 3, 4. Okay, so I have a dot there. Okay, then I'm doing -1, +1. Okay, so -1, +1. Okay, 0, 0. Okay, and then over 1, up 1. Okay, and then over 2, up 4. Okay, so now that we graph those, it's a curved line, it's not V-shaped, it's curved, okay, because we call it a parabola, okay, and then we're just going to connect, and it would look like this. Okay, we keep on going if we had more values in your graph, okay, and that is it, okay. This right here is the bottom of the curve, okay, and so we call that the vertex. Look at some patterns that are happening here. Okay. All right. I want you to write this. Oops, sorry. Okay, so this will be a pattern that you're going to need to memorize for all parabolas. Okay. So anytime you start at the vertex, as long as, go back here, as long as there is not a number right here and it's just the x squared, okay, so when we're looking at the x squared, if the a is 1, okay, this is going to be the pattern that you're going to have, okay. So from the vertex, you're going to go up, you're going to go over 1, up 1, so it might be a -1 and then up 1, okay, and then same thing, then you're going to go over 2, up 4, Okay, so if you look back here, okay, and we're looking at our parabola, okay, we went over 1, up 1. We went over 1, up 1, okay? Then from your vertex, you would go over 2, and then up 1, 2, 3, 4, okay? If you were to plug the value of 3 in here, right, plug in 3, then you would get 9. If you plugged in a negative 3, okay, you're still going to get 9. So that is our pattern. So then I'd go over 1, 2, 3, so right here, and then up 9, which if I extended this, you would see that. Okay, so you need to commit this, sorry, I keep on the graph there, commit this to memory, because anytime there's not something in front of the x squared, that is going to be where you're going to go for the next ones, okay? All right, so I want you to fill out both of these graphs, okay? I want you to do this one, okay? Plug in these values, tell me what you get, and then also do it for this one over here. Tell me what you get. Okay, so here are the values, so just check to make sure that you've got these right before we actually go to graph these. Okay, we're gonna do this one. We're gonna jump to a number 3 and then come back to this one. Okay, and looking at what is happening, and another thing that you're going to be memorizing with our patterns. Okay, all right. So if you got these, now we can go ahead and graph them. Okay, so I'm moving to an actual graph, so you can have yours just sketched on your paper. Okay, so the first one was a negative 2 up 5. Okay, so I'm going over 2, so 1, 2, up 1, 2, 3, 4, 5. Okay, so I got right there. Okay, and then I had a negative 1 up 2, so negative 1 up 2. Okay, and then I had 0 up 1. Okay, and then over 1 up 2, so over 1 up 2. Okay, and then over 2 up 5, so over 2 up 5. Okay, and then we draw our parabola. Okay, going like this. Okay, so what I'm wanting you to look at is the comparison of this one and the one that we did that was problem number 1. So if we're looking back here at my graph, okay, notice where the vertex is at when we had an equation that looked like this. Okay, so it was at the origin. Okay, well, what happens now when we added something onto it? Okay, going back over here to this graph, what happened to it? So when we had just x squared, it was right here. Okay, but then we had an equation that looked like this, and we added 1. Okay, so you should notice that the graph shifted up. Okay, so anytime you have just this, okay, we know that the origin is going to start at 0, 0. Okay, so we know what that parabola looks like. So it starts at 0, 0, and then you go over 1, up 1, okay, to the left, and up 1, okay. But as soon as you have this, this is shifting on the y-axis up 1. So you're shifting up 1, okay. So if that was a plus 2, then instead of it being at the base right here, then you'd go up 1, 2. And then from there, then you would do your over 1, up 1, okay. So we're going to practice this and see if you were just listening to what that graph looked like. Okay, so again, this one shifted up 1. Okay, so you are actually not going to create a t-graph. You are going to go straight to graphing, and this is actually your problem number 3. Okay, no table of solutions. Don't do x is negative 1, 1. Okay, because it'll take you forever if you have to do that all the time. Okay, so you are just graphing this one. Okay, so regular work. Hopefully that gives you enough time to pause the video. Okay, when it's just x squared, don't graph this. When it's just x squared, you know that it starts at the origin. Okay, and then we go over 1, up 1, over 1, up 1. We go over 2, up 1, 2, 3, 4, right? Because that's our pattern that happens every time when it's just an x squared. Okay, so now this one's different than the plus 1. So instead of going up 1 or up 3, because it's a negative, we're going to shift all of that down 3. So now, really my vertex is at a -3, so I'm going to go down 1, 2, 3. Okay, then from there, I'm going over 1, up 1. Okay, to left 1, up 1. Because remember, it's kind of like a reflection. Whatever I do the left side, I got to do the right side. Okay, over 2, up 4. So 1, 2, 3, 4. Okay, so over 2, up 4. Okay, and then over 3, up 9. So 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. So then that means that one's over here. Okay, so our parabola would look like this. Okay, so starting to memorize what those look like. Okay, so now this next one, okay, we're going to go ahead and go back to our table of values that we already had, okay, which was the one that you did back here. This is different than this. Okay, so when it's by itself and there's no parentheses, it's actually talking about the y. Okay, this is going to be a little bit different, okay, because it's being grouped together with the x. Okay, so we're going to graph this one. So you've got your tables of values, okay, graph it on a graph, and then we'll talk about what that looks like. So I'll give you a minute. You might need to pause the video. Okay, so in graphing your points, you had a -2 up 1, okay, so over 2 up 1. Okay, you had a -1, 0, so it just stays on the x-axis. Okay, and then 0 up 1, okay, and then over 2, so 1, 2, up 9, I didn't do that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, so it'd be right there. Oops. Oh my gosh, sorry. There we go. Okay, which would also be on the other side. Okay, so connecting those, okay, we would have the parabola. I'm just going to do this bottom part here. Okay, it would connect going up further. Okay, so now we're looking at what is happening, okay, when we had just x. We talked about it being at the origin, right? Okay, and then when it had a +1, it meant for us to shift up, okay? There's no parentheses around it, okay? It's the y that's being shifted up. Well, this time, what happened? Okay, we shifted to the left. We still stayed on the x-axis, okay, but we shifted to the left, which is actually a negative direction, okay? So memorizing this, what you're doing here is whatever, when it's in parentheses like this, you're shifting to the left or to the right, but you're doing the opposite of what is there, okay? So I want you to write this next to this problem so that you understand it. So when you have a parabola, because we already did that for number 2, okay, when you have a parabola and you have anything that's x plus or minus some number that's being squared, okay, the plus means you're going to move to the left. It's the opposite, right? We're not moving to the right, which is normally the positive direction. Okay, and then a negative is going to move you to the right. Okay, so just kind of memorizing, it's just part of math and what the procedures are. It's going to be a little bit difficult until you practice it. Okay, so when there's not parentheses, it's actually the y. Okay, starting at the origin that you're shifting up and down. Okay, when it's in parentheses, you're still at the origin, but you're either going to move to the left or the right, and it's opposite of what is there. Okay, so because this was plus, we didn't move to the right. Okay, we shifted to the left. Okay, so now I want you to try this one without using the table of solutions. Okay, so you are going to problem number 5 now. Okay, which is this one. So I just want you to sketch it. Okay, so problem number 5. No table of graphs, just sketching it. Okay, oops. Stupid board, sorry. Okay, we're just sketching it. We know the original would start at the origin and go up and down. Okay, but we just learned this now shifts it either to the left or the right. And it's opposite of what this is. Okay, so we're not going to shift in a negative direction going this way because that's negative. We're doing the opposite of that. So we're going to shift it to the right 2 spots. So it's at the origin and I shifted it to the right 2 spots. So that is my vertex now. And then remember, we go over 1, up 1. Okay, so over 1, up 1. Okay, and then to the left, over 1, up 1. And then over 2. So 1, 2, up. How many? 4, right? And then over 2, up 4. Okay, and then really, as long as you've got those, you don't need to do the 3 and the 9. Okay. So maybe just connect our, so it would look like that. Okay, so now we are not always going to have something that looks like this. Okay, so really when we go to do this one, this, if we were to write this out, so 2 parentheses, right, with x minus 2 written twice. Okay, really what we have is x squared minus 4x plus 4. So you are not always going to have it look like what it is in red. You're going to learn how to work with it when it's actually in a quadratic equation as well. So when it's like that in red, you're going to remember some of those rules, okay? When it looks like this, we're going to remember our second rule, okay? And what it's going to be, and we're going to practice that in just a minute. Okay, so now we're going on to number 6, and this one actually has table of values because we're going to look at what is happening now when we have a number in front. So all the other ones, we didn't have a number in front. Okay, we just had x squared, and then we added something to off to the right, okay, and had parentheses or didn't have parentheses. Okay, so I want you to plug in the table of values for this one and this one, okay? And the first one is actually number 6, because we're going to look at what it looks like, and then you're going to try it minus doing a table of value, and this will be number 8. Okay, so number 7 will be coming up. So if you need to give yourself some space, I probably should have been telling you that on the previous ones. Okay, so this is number 6. So plug in your values for both of these, okay, and then also do it for this one. I'm going to pause the video, so you might need to do that as well. Okay, so before we go to graph, because it's on a separate page, check to make sure your values are the same as what I got. Okay, so you should have 12, 3, 0, 3, 12. Okay, and then a -4, -1, 0, -1, and a -4. Okay, so what we're looking at now, okay, just for this one right here, is there's something that's happening to our pattern, okay? So when we had the pattern before and it was just x squared, right? It was from the value of 0, okay? It was over 1, up 1, okay? And then from the next one, it was over 2, up 4. What is happening to the right side? It's still over 1, okay? But what is happening to the right side? It is being multiplied by 3. So anytime you have your pattern, so let's go graph this now, okay? We're going to go graph those. Okay, so you had a -2, up 12, so -2, so we start at the origin because we had a 0, 0 on there, okay? So we go -2, so 1, 2, up 12, which is going to be on my graph. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And then I had over to the right 2, up 12. And then I had a -1, up 3, so -1, up 3. Okay. And then I had a +1, up 3. Okay, so if you notice, I'm just going to do a different color. When we had our just x squared, we always started at the origin, but we went over 1, up 1, right? So now, what you're doing when there's a number in front of it, okay, so we had 3x squared, right? So instead of over 1, now whatever direction you're going up, you have to multiply by 3, right? So it used to be over 1, up 1. Okay, so then you times this by 3. Then it was over 2, up 4, and then you times that by 3. Okay, so the same thing with this one. This was over 3, right? And we went up 9, which we're not going to do this last one because that would be way after that. Then that means you would have to go up 27. Okay, so when there's a number in front, your pattern you'll remember, okay, it's still over 1, still over 2, still over 3. But the direction that you're going up, you're going to multiply it by that number in the front. Okay, so connecting that, go ahead and connect it on yours. Okay, and then we're going to go to number 7. Okay, so on number 7, I don't want you to make a chart. I just want you to graph. Okay, and you only need to graph 3. So you're going to start with your 0, 0. Okay, so start with your 0, 0, and then show me what it would look like for your over 1 on each direction. Okay. All right, so we start at 0, 0, right? Okay, because that's what the x squared would be. But now when I go over 1, I'm not going to go just up 1. I need to multiply that by 5. So I'm going over 1 up 5. 1, 2, 3, 4, 5. Okay, so now I go over 1, and I'm going to go up 5. Okay, so really all that this does is it stretches the parabola out. Okay, so instead of being just a little bit more wider with the U-shaped, it's stretched out kind of like a rubber band. Okay, it would be stretched out when you're pulling it up higher versus over 1, up 1. Okay, so that's what that would look like. Okay, so now let's go back to number 8. Okay, so number 8, when we go to graph this one, okay, we're going to go, we still start at 0, 0, okay, but we're going to go over 1, down 1, and then to the left 1, down 1. Okay, so let's see what this graph looks like. I think I have to draw my own. Okay, so I'm just going to sketch it out for the second. Okay, so number 8, okay, when we go to graph this, I'll do a different color. Okay, so I still have my 0, 0, so I'm going to start there, 0, 0. Okay, so I've got that one done. I'm going to do the negative ones first. Okay, so I'm going left 1, down 1. Okay, so that one's done. I'm going to do this one, so to the right 1, down 1. Okay, so that one's done. Okay, and then I'm going to go to the left 2, so 1, 2, and then down 4. And then to the right 2, and down 4. Okay, so what do you notice that is different between this one and when we had this one? Okay, so when we had this one, we always said that it started at the origin, we'd go over 1, up 1, over 1, up 1, right, over 2, up 4. Okay, so the difference between this one and this one isn't much difference. It's just being flipped upside down. So all of the parabolas that we've been doing have had positive numbers in front. Okay, so all of them have gone upright. Okay, so anytime you have the negative, you're following the same procedures, except now you're going to flip it upside down. Okay, so it'll be going down in a negative direction. Okay, let's see if you can put this all together before we move on to some other, the second method that I was talking about when we actually have it written in quadratic equation. Okay, so this is number 7. I'm going to work through it. Actually, not number 7. This would be number 9. Sorry. Okay, so no chart. We're going to put it all together on the things that we just learned. Okay. All right. So when the very first step that we're looking at, okay, and we're going to use what we call the transformation because we're not using the chart. Okay, so there's no chart that we're using. This is called using transformation because we're shifting things. So if you remember from geometry, we had transformations, which means a disc slid. Okay, so we know what the parabola is supposed to look like, but we're either sliding it up, down, left, and right. Okay. So this first one, if we started at the origin, okay, we already know that this is going to be upside down, right? Okay, so we're going to wait on that part, okay? So the first thing we're going to do is we are actually going to do what? Are we going to move to the left or are we going to move to the right? So if you look back at problem number 5, okay, we had a negative 2. But we didn't move to the left, we moved to the right. Okay, So for this one that we're doing, our first step, okay, our first step, because that would be order of operations, would be to do the parentheses with a 2. We're going to move to the right 3. Okay, so from the origin, I'm moving over 3. We're not going to make a dot yet. Okay, so I'm going over 1, 2, 3. So this is where I'm at right now. Okay, then from there, this one tells me the direction of my y. We don't do the opposite of that because it's not in parentheses. We do the actual direction that it is. Okay, so that means I'm going to go down 4. So 1, 2, 3, 4. Now I'm going to put my dots. Okay. Okay, so from there, that is my vertex. Is my vertex going to be going upright or down? And you should have said down, okay? And then this is like having the negative 2x squared, okay? So we're not going to go over 1, okay? Over 1, up 1, or down 1, I guess, because we're pointing downwards. Okay, remember when it's by itself, that was the pattern, was over 1, right? Up 1, over 2, up 4, okay? So remember, with this one, we got it in multiplied by 2, okay? So you know it's going downward, so I'm not going to go to the right and up, okay? We're going to go to the right, but now instead of going up times 2, I'm going down times 2. So 1, 2. So there's my second dot. Okay, so for this one, I'm going over 1, but I'm going down 2 because I'm multiplying it by 2. Okay, so remember the next one, which we're only going to do these first ones to get the directions going, but on the next one, you would go, instead of over 1, you would go over 2, and then the pattern was to go to 4, right? Okay, so this one we're multiplying by 2. So if I go over 2, I'm actually going to go down 8. So if I go over 1, 2, I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, forgiving me, we'll go right there. Okay, so go over 1, 2, and then down 8. Okay, so then we would have our parabola that looks like this. Okay, so the first part was this part. Okay, second part was this part. Okay, which tells you which direction to shift it. So we went down 4, and that's the vertex. Then from there, you remember your pattern. Okay, over 1, up 1, over 2, up 4. Unless there's a number that is in front of it, then your second part is over 1, but then you have to times that by 2, okay, to know where it's going to be at. Okay, so now we're going to learn our next method. So this is going to be problem number 10. And you will need to pause this video so that you can write this down, okay? I'm going to scroll pretty quickly so that I can get through this video, and then you guys need to pause this. Okay, so hopefully you got all of that written down. Okay, so our second method that we're using is when we have things written in the quadratic formula, okay? So when it's written in the quadratic formula, there's a new method that you can use. And so again, we still have values, okay, that are to the left and to the right. We have our vertex, and if you notice where the vertex is at is halfway in between. So the direction that we go this way is the same direction that we would go this way, okay? Finding out where the between part is at. So the between part means you're splitting it in half, right? So where the vertex is at, it is located halfway in between the distance of these two, okay? So that's where this is coming at. So the vertex lies between the x-intercepts. So whatever these two x-intercepts are, this one and this one, halfway in between it, when we go straight down, is where the vertex is going to be located, okay? And that's when the y is 0, okay, because it hasn't gone up, it hasn't gone down. Okay, So x-intercepts are solutions of a quadratic equation. So once we actually find out what the x-intercepts are, okay, then we can plug it back into the equation. So if I know, just like all the graphs that we did, when we picked 0, we could plug 0 into this equation and then solve it down, and then we would be able to plug in our y, because that's what we did on the previous ones. You plugged in those values. Okay, so there's an actual shorter way to do it when it's written in quadratic format. Okay, some of the ones that we did back here, okay, not this one, these guys were not written in quadratic, so it's easier just to do it the method that we were doing. Okay, so this one right here, if we were to actually multiply this out and have it written in quadratic formula, it would look like, not this one, sorry, let's go back here and I'll add a page. It's, if I did the parentheses first, okay, then distributed, we would have a negative 2x squared plus 12x minus 22, okay? So what we're solving for first is what is the x-axis, okay? So we're trying to figure out the x location and then plug it back in to get the y location. Okay, so according to this formula right here, we only use this part of the quadratic formula to find out what the x is, okay? So this is where this comes in. So we need to know what the b is and what the a is, and we simplify that down, and that is going to be our x coordinate, okay? So if you go to this problem right here, my b is 12, right? Oops. My b is 12, and then my a is a negative 2. So it's negative b over 2a, right? Okay, so if it's negative b, then that means it's going to be a negative 12. Okay, then on the bottom I have 2 times my a. Well, my a is a negative 2. Okay, so this would be a negative 12 over a negative 4. Well, if you simplify that down, that would give me 3. So my coordinate is 3, or my x value, okay? So now to get my y value, I just need to plug in 3 to all of those spots, okay? So when I square 3, because that would be order of operations, that gives me 9. So now I'm at a negative 2 times 9, right? And then I've got 3 times 12, which is 36, and then minus 22. So this would be a negative 18 plus 36 minus 22, okay? Which simplifies down to a negative 40 plus 36, which gives me a negative 4, okay? So this is my vertex. So if you go back to the problem that we did that was written out the long way, okay? If it's written in the quadratic formula, this will be much shorter, okay? So going back to this one, our coordinate here was over 1, 2, 3, and down 1, 2, 3, 4. That's our location of our vertex. Okay, so that's what this one is right here, right? Over 3, down 4. Okay, so now all you have to worry about when you go to graph this is that's the location of the vertex. We know it's a negative, so it's going to be pointing downward, okay? And then your over 1, down 1 needs to be multiplied by 2, which it was, okay? When we did this, we went over 1, down 2, okay? Over 1, down 2. So just that comes back into play for the quadratic equation. Okay, so you guys are going to try this on this one. Okay, I can see how you did. Okay, so we have A's and B's that we need, right? Here's my A, here's my B. Okay, so the equation is a negative B, but I have a negative 6. So that means it's going to change from a negative to a positive when I plug it in. Okay, so 6 instead of a negative now. Okay, so now I have 2 times A. Well, 2 times 2 is going to make it 4. Okay, so technically we want to work with smaller numbers, so we're going to reduce it. So you can leave it as a fraction, but if it can simplify to a terminating decimal, I would do that. It makes it a lot easier to plug in, okay? So that is my x value. So my x value is 1.5 or 1.5, okay? So now we're going to plug it back into the equation, and decimals are going to be easier to plug into your calculators. So wherever the x is at, I'm going to plug in 1.5, right? Okay, so I have 2, and then I have 1.5 I need to square first before I multiply it times 2. And then I'm going to have 1.5 that I'll multiply times 6, and then do all my adding and subtracting. Okay, so this winds up being 2, and then 2.25. Okay, so multiplying those two would give you 4.5, and then minus 9 plus 1, and then going left to right, you're going to wind up with a negative 3.5, negative 3.5. Okay, so when I go to graph it, let's get a bit color down here. I'm going to go over 1.5, so here's 1, here's 2, so I'm going to go halfway in between, okay? And then I'm going to go down 3.5, so I've got 1, 2, 3, there's 4, so halfway in between. This is right there. Okay, so that is my vertex. Okay, so now you come back to this. Okay, it's a positive number, so because it's a positive number, it's going to be going upright, not upside down. So the parabola is going to be going this direction, right? Okay, so remember it used to be over 1, up 1, and over 2, up 4. But we've got this number in front, so that means the over 1, and then the second part, which was up 1, you have to multiply it by 2. Okay, so we're going over 1, which will be the halfway mark, right? So we're getting the halfway mark, so we go over 1, but we're going to go up 1, but we have to times it by 2. Okay, so I'm at a 3.5. Okay, so I'm going to be going up 2. So 1, 2, so that means it's going to go right there. Okay, and then the same thing's coming on this side. Okay, so I'm going over 1, which is going to put it in the halfway mark, right? And then I'm going up, and I'm timesing it by 2. Okay, so it's going to go right there. So again, on these, just as long as you've got the left side, right side, the vertex, you only need to do 3 of the coordinates. Okay, so that would be good on one side. Okay, so to finish this out, this is actually super quick. The second objective, objective 93, has to do with shading now. So you just need to remember how we shade things. So we're still going to be using the information that we learned in objective 92, except now you're going to be doing some shading. So back here we had equals, so it's just the line itself. Okay, but now when we add the inequality, then you're going to have some shading. Okay. So if you remember from earlier in the year and algebra, we used the equation y equals mx plus b. So y equals mx plus b, when you go to graph it, it just winds up being a straight line. Okay? But then as soon as we add an inequality, we've either got a solid line or a dashed line, right? And then we're either shading above or below, depending on what is facing the y. Okay, so if this was my line and now I have this inequality, the y is bigger. So y's get bigger when they go this direction. So that means when I do the shading, I would shade on this side. Okay, so the only difference between this first one and the second one is notice that there's no equal sign below it. So when we go to graph that same line that I just had, it just won't be solid, it's going to be dashed. So you'll have to pay attention when you're doing your parabolas, if they're going to be a solid parabola or a dashed one, and then your shading obviously isn't a straight line, it's going to be a curved line. But this one would still be shaded above. Okay, so if we were to do this one, pretending it started at the origin, okay, and we have our parabola that's going like this, okay, if I'm looking at this part right here, I would have done that problem wrong because I made it a solid shape. Okay, so it should have looked like this. Okay, so it should have been dashed, going through that location. Okay, and then the part that's facing the y is bigger. Y's get bigger going this direction, so you just shade inside of the parabola. Okay, if it was smaller, which it's not, so don't write this. Okay, if the y was smaller, then you would shade this direction because all the y's get smaller on the outside of the parabola. Okay. So we're doing the same thing. Okay, let's see if you can remember from the previous section what this graph would look like. So I want you to graph this. Okay, remember you're not using a chart to plug in values. You're using the negative b over 2a, okay, and then plug it in to get your y, and that's your vertex, okay. This is going to be an upright or downright parabola, okay. You don't have to multiply it by anything, so it's still going to be the over 1, up 1, or down 1, I guess, because it's negative, okay. So plug in your a and your b. Let's see if you can do this. I'm pausing the video. I would like you also to pause the video to see if you can get this right. If not, then you can fix it. You'll have one more to try before we're done. Okay, so plugging in your value, you've got your a and your b. So your b is 6 and your a is a -1. Okay, so plugging it in, checking to see how you did. Okay, so it's negative b and it was a +6, so it'll be a -6. And then 2 times -1 gives you -2. So negative divided by a negative should have given you a positive. So there's your x, okay? Then I plugged my x back into my equation, okay? So I squared my 3 and then changed it to a negative. 6 times 3 gave me 18, and then adding and subtracting left to right, I got 2. So my x is 3 and my y is 2. So that is my vertex, okay? So my x is 3 and my y is 2. Okay, so I'm going to go graph that. So I would go over 3, so 1, 2, 3, up 1, 2. Okay, so there's my vertex. Okay, it's negative, so that means it's going to be going down, right? I don't have to worry about the multiplying my number that shifted anymore. It's still over 1, okay? But it's going down, not up 1, right? So you go over 1, down 1, over 1, down 1, because you're multiplying it by a -1. Okay, then we go over 2, down 4, 1, 2, 3, 4, over 2, and down 4. Okay, so it looks like this. Okay, I had a solid line, so it's a solid parabola, but now I'm looking at the shading. So the part that's facing the y is the smaller part of the sign. So smaller on y's go this way, right? So you're shading inside the parabola going this direction, okay? So that would be your shading, okay? If it was greater than, which it's not, okay, then the shading would be on this outside, okay? So don't write that because it's not, okay? It was less than, so it would be on the inside going downward, okay? Because those y's get smaller going down. Okay, I want you to try this one. Again, I'm pausing the video. You need to pause the video to try it. See if you've got this, because you're going to be doing the try it next. Okay, so your x values you should have got was a -0.5. If you had a -1/2 fraction format would be fine. Okay, and then plugging it back in, you would get a -3.25 or a -3 1/4. Okay, so we graphed it, and it was really hard because my thing doesn't pinpoint, but as long as you get in proper location, you're close enough. Okay, so I went over a half, so not quite a whole. Okay, and then I went down 1, 2, 3, and then just beyond and made my vertex. Okay, and then from there, you're just going over 1, right? Up 1, and then the same thing going that direction, and then you would go on over 2, so right there, and then up 4. Okay. But notice there's no equal sign. So it's not a solid line. It should have been a dashed parabola when you connected it. Okay. And then the part that's facing the y is a smaller part of the sign. Well, the smaller part goes this way. Okay. So it's on the outside of the parabola is where the shading would be. Okay. All right. Try it. We will grade on Monday. Do the best at your sketching, and we'll review questions as needed on Monday. Have a good weekend.